All right, we're going to start here in the middle of problem number 4 off of last night's homework. I'm just going to kind of show you how we could do this one. The key on this one is actually incorrect unless it gets fixed by tomorrow. So you can see what the right answer is for number 4 right here. All right, so now I need to shift this plain cosecant graph over this far. Notice it's this far, not this far. I shift it this far. I'm going to shift it pi over 4. How far is pi over 4? It's this far right here. So it's 2 marks. So I'm going to grab this and move it over 2 marks. 1 mark, 2 marks. 1 mark, 2 marks. Now I got to move the rest of it. There. That's where it should be. Get that? Now that's 1 period of pi. Does it want more than 1 period of pi? Yeah. It wants 2 periods of pi. Then I need to get rid of this sign here and put in another couple. Well, it's pretty easy to follow this pattern. I'm going to go over from this is over 2 marks from that. So I go over 2 marks from this and make another up circle. And then go over 2 more marks, which would be like right about there. And do another down circle, or that circle parabola. There we go. And now there's only one spot that's not labeled. This spot right here. And I better label that or I won't have... Oh wait, no, there's some spots over here that has to be labeled. My bad. Negative pi over 8. Negative pi over 4. I can just copy down the same thing I had here and here. And then the last one is, let's see, 1/8, 2/8, 3/8, 4/8. This is 5/8 pi. There we go. Now I got my 2 periods of cosecant. Questions? Yes. Gotcha. Right now I believe I'm recording the entire, like the whole board, not the thank you. There's normally a red border around what I record, but I'm recording the entire screen this time, and that's okay. Yes?
Could you just like draw the normal cosecant with the normal numbers and shift it pi, then change the period?
Yes. If you do it in the right order, you're fine. But see, the kids that go and change the numbering first and then try to shift it pi are the ones that are going to get it wrong. If you shifted it pi first and then renumbered it, that would be okay. All right. Either way you slice it, that's the right answer. Again, you could do it either way and it would work. Just trying to show you an alternate method. I think from talking to other teachers that this is the way that kids are least likely to mess it up, is if they do it this way. But if you want to do it this way and you just do it in the right order, that first and then this, then that's okay. Yes? If you were talking about what order should you do it in and you had the black one here and you didn't rewrite it, then you should say, to start with, you would normally do the multiply first, so you don't. You do this first. You do a shift of pi to the left, and then a shrink 4 times narrower. But if you'd rather do this one and give me these answers, I would accept it, which would be first shrink it 4 times narrower, and then move it pi over 4 to the left. That's also a right answer. Yes?
So, because of how the functions work, don't you have to do the shifting first anyway? So why is the first one?
If, I understand what you're saying, if you do it in the right order, you'll be fine. But kids' first instinct on most of these problems is, if you hit like sine 4x minus pi, is they're going to go, okay, I got to renumber it. And they start renumbering right away. If you do the shift right away and then do the renumbering, you'll be fine.
So as long as you go in the right order, you don't have to worry about changing it.
Correct. This is also, do you remember that little debate that we were having about whether or not which one of these two was a phase shift? Do you remember how on that little section where Mrs. Richens was saying we should take this and set it equal to 0 as a shortcut way of doing that? Watch what happens when I do that. 4x minus pi equals 0. 4x equals pi. X equals pi over 4. Do you get that the phase shift is pi over 4? She's getting that number right there. Okay, so I was saying that, hey, you can do it this way too and it'll still work. Well, that's true. I just proved it. I just showed you that you can do it this way or this way and it'll give you the right answer. So I was objecting to having to do this. I wanted to just say, this is still a shift of pi. You just have to do it in the right order. And so I agree with you. You can do it either way. But this is a way that oftentimes ends up working better on more complicated problems if you renumber it first. See, this would force you to do this first. Renumber it first and then move it a smaller distance. Because this will always be a smaller thing than it was. Okay. Next, let's talk about the difference between tangent and cotangent. I want you to just get a fresh graph and sketch me tangent. And label the first two spots that are important. I want to see if you make one of the really common mistakes on tangent. All right, first of all, tangent runs right in there. And it goes up as you read from left to right. So things are looking up when you're getting a tan. And things are cold and not when you're not getting a tan. Cotan. Cotangent kind of goes like this, but they doesn't go right there. Remember, cotangent is shifted over here somewhere. We'll talk about that in a minute. So here's tangent, and it goes from pi to negative pi. True or false? Why not? I thought it had a period of pi. All right. This is, the whole thing has to be pi, and therefore that has to be half of a pi, and that has to be half of a pi. All right. Good. Now, would you please graph cotangent? See if you know where cotangent goes.
Yeah, that's cool.
And now, if you got confused with tangent, you might think that this would be pi over 2 over here, but it's not. It's what? Right there. Just pi. Yes. Okay. Yes.
If you want us to just draw one period of tangent or cotangent.
Yep. That is one period of it. If I needed another, I could go like this. Now I got 2 periods of it. Shall I continue? Yes?
So, do you want us to do the 4 tick marks then on the x-axis?
Good question. Yeah, if I was grading this graph the way it is, I would mark it wrong because it doesn't have enough labeling. You should have everything labeled wherever you have drawn a graph.
Okay, so it's one period of pi. You want
So I really should have put the pi over 2 right here also, but I didn't. I'm just going to say I should have put that there. So if I'm going to make 2 periods of pi, now I should put marks here and here and say half a pi, pi, this would be 2 pi, and this would be 3 pi over 2. And let me make sure I haven't missed anything else. I've got my asymptote lines. Oh yeah. Now if I don't label those, I am not, teachers can be different on this, but I personally don't mark them wrong if you have not labeled those, because to me that means you're defaulting to the standard, which for 1 mark would be 1. So I'm going to assume you meant 1 and -1 if you don't mark those. All right. Yes, this is 2 periods of pi. If you, of course, want to stretch the thing, then you should definitely have this labeled. So if it was like, if you don't label it, I'm assuming you mean 1s. And if there's really supposed to be a 3 and a negative 3 there, because you're graphing 3 tangent of x, then you better have the numbers in there or you'll get it marked wrong. Okay? Yes?
Where everyone actually on the point where the tangent functions cross the basic line, like the 1 and negative 1.
Ever's a big word. For this test, no, that's outside the scope of this test. All right, so for your next trick, see if you can write down in the right order what changes I'm making to cosecant here. Make me a list. Check it twice. There's 4 things. What are they and in what order? All right, first of all, I say start on the inside. So if I'm going to start on the inside, this is a multiply problem. And therefore, normally that would be first. So I do that first because I'm supposed to do counterintuitive on the inside. So it's right pi. Next thing, it's this one. And that's not narrower, it's getting wider. Stretch, factor, horizontal stretch, factor 3/4. Next, I go to the outside and I do it in the normal order. But of these two, in gymnastics, would it be smarter to stretch before you flip? Yep. So I probably should do that stretch. And it's 2 times taller, also known as a vertical stretch, factor 2. And last thing is a flip, or an up-down flip, which is a reflection over x. There is a right order. Is there any other right order? Yep. Yes? Yes, here's the key word. If I get the word stretch in there, I'm fine with you saying 4/3 or 3/4. Both is fine, as long as you have the right, you get across the point that it's getting, in this case, bigger. Okay? But if you get the wrong word there, then I'll mark it wrong, no matter which factor you have. If you said it was a shrink factor 4/3 or 3/4, I'd say you're wrong, because it's not shrinking. If you're saying it's stretching, I can go with either of the numbers. Yes?
Is this potential, even though we're not graphing, is this a potential question, test question?
Absolutely. That's why I keep doing it over and over again.
Would this be in R3 or R4?
Which problem number will this be?
No,
I'm not telling you anymore. Just know that you need to know how to do this. Otherwise, I wouldn't be spending so much time on it. Yes?
So would it be wrong to swap steps 1 and 2 there? If we factor everything 3/4 x minus
If you wanted to change this to 3/4 x minus, what would that turn into? 4/3 pi? If you did that, that'd be okay. And then you'd have to use the new numbers that you just made. And then if you changed it to this problem right here, then you got a new set of numbers to use. And you'd start by, let's see here, and it also needs one more set of parentheses. There. And then negative on the 2. Okay. There. Now there's my new problem. If you rewrite it that way, then you may use those and do it in that order, which would be, let's see, normally you do parentheses first, so you don't. You do this first. That'd be first. This would be second. This, always stretch before you flip, so this would be third, and this would be fourth. Okay? All right. So, let's try one more that kids often mess up, and it's tangent. Because remember that thing about tangent's going like this, and people think, oh, its period is pi, so I'm going to put a pi here. Same idea, that'd be wrong. It's pi over 2 because the total distance is pi. Same thing happens on more complicated tangent problems. So let's try one. 1/2 tangent of 1/3 x. Try that. Graph it. Just graph it. Make a sketch. Parent. Things are looking up when you're getting a tan. Normal numbering, pi over 2. But it's not going to be normal numbering because of that. So you'd say period is normally pi divided by the 1/3, divided by b, and the b term here is 1/3. So divide by 1/3 means times by 3. So it's 3 pi. So this should be 3 pi way over here. No, it shouldn't. The total should be 3 pi from here to here. So if a total is 3 pi, we want half of 3 pi. So that would be 3 pi over 2. Raise your hand if you had that right. Excellent. Yes. You might actually get a good grade this time. Marzano. It's got it in for you, I know. All right. Let's see. Oh. All right, let's move on. So if this one's 3 pi over 2, is there any reason I would ever want to put in another one of these things? Like this? Yes, if they ask me for 2 periods. So please look for that. If they ask you for 2 periods, graph 2 periods of it. And then you have to label it farther too. So that can be a challenge for some kids. 3 pi over 2, what's the next mark going to be? 6 pi over 2 is the way I do it. And then I can simplify that down to what? 3 pi. But 3 pi over 2, 6 pi over 2, 9 pi over 2. See how I'm just counting it up by even little increments there? All right. On that note, I want to practice with you. Let's say you are doing your conversion, and it's normally 2 pi here for one of your sine or cosine kind of deals. And let's say you get something weird, like 7 pi over 10. Would you please try to number the other 4? See if you know how to handle that or not. Yes. It is okay if you do not simplify those fractions of pi this time. So if you have like 6 pi over 10 and you left it that way, on this test, I'm okay with that. Okay, so 7 pi over 10, what the heck? I can't do half of 7 pi and say 3.5 pi over 10, because you can't have a decimal in the middle of your fraction. So 7 pi over 20. And then half of that would be 7 pi over, but this last one will separate the little kids from the young adults. 7 40ths, 14 40ths, 21 40ths. Raise your hand if you had those right. That's most of the class. Good job. What? Okay. The last one is, there's one, it's like 1, this is like 2, this is like 3, right? 3, this is 3 times as big as this, right? So you just take this times by 3. So 7 times 3 makes 21 40ths. All right, let's do one more like that, see if you're, this will be simpler. Let's say it's 2 pi over 3. do the halvesies thing. Half of 2 pi over 3 is 1 pi over 3. If you said 4 pi over, or sorry, 2 pi over 6, that's fine. It's the same thing as what I said. All right, and then half of this one, you go pi over, and if you can't take half of the pi, you take half, you double the denominator, pi over 6. And if it's 1/6 pi here, this would be 2/6 pi, which reduces to 1/3. 3/6 pi. And I'd really prefer it if you notice that you can reduce that. 3/6 pi would be 1/2 pi. But it's okay if you forget. Pi over 2 is the same as 1 pi over 2. Either way is fine. All right. Are you feeling like you're going to be okay on this test? I think most of you will be. And you never feel like you're going to be okay, so I'm not worried about that. Okay. So, here's what we have now. I have assigned you the first half of the worksheet yesterday. Now I want you to finish the worksheet for today, and we take the test tomorrow. And today's a good work day then to, just ask questions. Mrs. Redepenning has been with me answering questions all day. She can answer the questions too, so like last hour I was having 3 or 4 people at once needed answers. I'm happy to answer some, but she can answer them too. All right, yes?